Hi, I'm Bill Buzbee, and this is Magic-1, my home-built mini-computer. It's been 6 years since I made a video about Magic-1, and that video I made 6 years ago was on the 10th anniversary of Magic-1 coming alive and computing Fibonacci of 10. So actually, Magic-1 has now been running continuously, blinking away for 16 years. Anyway, thought it would be good to make another video about Magic-1, but also to give a little bit of news. And so let's start with the news. I'm recording this in late February of 2020. In March, on March 21st and 22nd, I'm going to be taking Magic-1 to Seattle, Washington to show it at the Vintage Computer Festival Pacific Northwest. I'll leave some information down in the description of the video about the show. And if you're in the Seattle area, come on by. It should be a good show, and you can see Magic-1 in person and even play around with a VT100 to talk to it. But anyway, let's go on with today's video. So what I thought, one of the reasons why I haven't made a lot of videos lately about Magic-1 is because on the hardware side, nothing much has really changed. Magic-1 is very solid. It's been chunking away and happily blinking, connected to the internet and serving web pages. But I thought it would be a good idea to talk about another aspect of the project, the software side. Now, when I talk about Magic-1 and people come to see it, very typically, most of the interest is around the actual hardware construction. How did I actually build this thing? And for example, here is one of my early wire wrap cards. This is the old memory card. And looking at these little wrap wires, people think that this was an enormous amount of work, and it was a fair amount of work. But in truth, the hardware construction, the hardware aspect of building Magic-1 was pretty small in terms of total effort. It's really the software. The software is the huge time sink, I guess kind of like an iceberg. This hardware bit is the stuff sticking out of the water, but an enormous amount of effort went into the software to turn it from a working computer into a useful working computer. And so in today's video, we'll talk a little bit about the software, and there has been some new things on the software front. But let me switch the camera around and we'll get rolling on that. So while I'm going to talk about the software aspect of the project, let me go ahead and kick off a little program here to make some good blinky-like patterns in the background. So there'll be something interesting to watch while I'm blathering on. Okay, so let's roll back the clock and go back 16 years to when Magic-1 first came alive. Honestly, 16 years ago, the hardware for Magic-1, the capabilities of the hardware are really not much different than it is today. But as far as being a computer, Magic-1 is just vastly more capable than it was back in the early days. And the difference, of course, is that I had essentially no software at the beginning of the project. But right now, it has a pretty full and deep, complete software stack. So in the very beginning, there were only a few ways that you could create a program for Magic-1. And probably the most elemental way would be to essentially do it by hand. You could write out a few opcodes instructions and then convert them by hand into their binary equivalents, and then use the front panel to actually enter them into the computer. Now the front panel, it's mostly decorative at this point, but it actually is a functional thing. These switches here will kind of select which memory location to look at, but they also have the ability to change the value in that memory. And so for toggling in your own program, you would assemble it by hand, identify what the binary values of the opcodes are, and then you'd set up the addresses of the program on this line. You would put the binary value of the opcode byte here, and then press the write button to write a single byte into memory, and then you repeat that for the next byte. And now obviously this is something that you would not want to do if you had more than a dozen or so, or a couple dozen instructions. And in fact, I think I only did it once or twice just to prove to myself I could. The primary way of getting programs onto Magic-1 in the beginning was with an assembler and assembly language. So assembly language is basically a text version of the instructions that Magic-1 understands. But obviously Magic-1 can't just read a text file. So you need another program, an assembler, that will read in the text file of the assembly language instructions and then create the binary image that can actually be executed on Magic-1. And of course, there was no assembler for Magic-1 that I could go buy, so I had to write that myself. It wasn't that difficult, but I did that fairly early on. And with the assembler, and actually just for you assembler folks, it was an absolute assembler in the beginning. My real goal was to get a C compiler, or get the ability to run C programs, because that would open up a whole world of software, and it would also make it easier for me to write software. So I thought about writing my own C compiler, but decided I really wanted to spend my time elsewhere. And I looked at different existing compilers to see which I might be able to modify to generate code for Magic-1 instead of whatever target they were originally generating code for. And I ran across a compiler called LCC, which was actually designed to be easily retargetable to different machines. And in fact, it was. And it was kind of a really nice compiler, great experience. So you basically write a description of your computer architecture, a machine description, as a text file. You compile that as part of building the compiler, and then the resultant C compiler will generate code for your device. And I did that actually very early on in the development process of Magic-1. And so that made life a whole lot easier, because then I could start running C programs on the machine. But even then, there's a lot that has to go on, because if you ever do any C programming, there are the language constructs of C, but there's also the C library, libc, which everybody who does C code relies on. And this has functions that do things like print to the screen, open files, close files, copy memory from one place to another. And of course, in the beginning, I didn't have a libc. But fortunately, the Minix distribution included a source code for their version of libc, and I just basically ripped that off and ran it through my retargeted C compiler and created my own libc. But once again, the next step, just having a C compiler and an absolute assembler wasn't enough when you start dealing with libraries. I actually needed something called a linker, which will take different fragments of programs, and including libraries of functions like libc, and pull them all together and stitch together a resultant executable. And of course, obviously, there was no linker available for Magic-1, so I had to write a linker. And then there's some other associated tools, AR, which creates libraries, and ranlib, and various other little things like that. And so the point of this is there's actually quite a lot of software work that needs to happen before you can start using significant amounts of software on a machine like this. And doing all this probably consumed, the first year or two after Magic-1 came alive. But once I had that in place, it was actually started moving fairly fast at getting Magic-1 becoming more and more capable as a computer. Fairly soon after Magic-1 came up, I used my C compiler and assembler to create a very simple operating system. Actually, I think I prefer to call it a monitor, that allowed me to load and store program images to disks. It had some rudimentary file system, and this monitor is what actually Magic-1 ran on for the first several years of its existence. But while it was doing that, that's when I really dug into my ultimate goal, which was to get Minix, a full-blown Minix running on the machine. And I don't have anywhere near enough time. I don't want to make this a super long video, but getting Minix up on this machine was by far the hardest part of the entire project. It swamped the difficulty of actually designing and building the machine itself. but there was a lot of things you had to work through to get Minix up and running. But it did, and it's working great. And once that happened, once I had Minix up, and then I could compile all these hundreds of built-in commands to Minix, like sort and PS and all the typical things you'd see, then Magic-1 very quickly became what I consider a real computer. And after that, that's when it started serving web pages and supporting telnet sessions and text editors and the whole shebang. And so that became very nice. Anyway, I don't want to make this a very long video, but let me just say if there's parts of this process of bringing up the software stack that folks are interested in, leave a comment down below. And if there's enough interest, perhaps I can do a special video or talk on particular aspects of getting the software stack up and running. Okay, so now let me just end this portion of it by just repeating again, the hardware was hard and it was fun, but there's an enormous gulf between having a functional computer and a useful computer. And that gulf is bridged by software, and it's a lot of work to get it all together. Okay, so let's talk a little bit now about some of the things that have happened in the last 6 years. As I said, not much has changed on the hardware side, but on the software side, I have some interesting things going on. I typically don't do much with Magic-1 these days, but every now and then I'll kind of get the urge and I'll decide that I want to get something new running on Magic-1, like a game, or more importantly here, one of the things that bothered me about Magic-1 is that all these tools I've been talking about, the assembler, the linker, the C compiler, they don't actually run or didn't actually run on Magic-1 itself. And the reason for that is that Magic-1 is fairly limited as far as per process memory. So every program that runs on Magic-1 can have at most 64 kbytes of code and 64 kbytes of data. And the assembler and linker and C compiler, at least they use vastly more memory than that when they're running on the Linux system. The code that I wrote, I could have written it so that it used less, but it seemed to me to be not a useful use of my time when it's much harder to write code that takes up very little memory than it is to just go ahead and don't worry about it. I'll just go ahead and blow the memory because I've got it. I've got this powerful desktop that has gigabytes of RAM, and I was shooting for going for something quick and make it work. But it would be nice, I thought, if I could at least do some programming on Magic-1 itself. And to do that, I would actually need to have my assembler, at minimum, my assembler and my linker actually run natively on Magic-1. And I'm happy to say that now they do. It took a bit of work and they're not very efficient, they're kind of slow, but you can actually now do some programming on Magic-1 itself. And let me change the camera around and kind of go to the screen and I'll show you some examples of what we can do with that. Well, I wanted to do this part of the video using the old VT100, but the video looked kind of bad because it's a difficult thing taking video of an old school CRT monitor. The frame rate of the display and the camera don't mesh up well, and it looks kind of strange. So what I've done is I've switched over to my laptop, and I'm running a terminal program on my laptop, and I'm connected through a serial port to Magic-1. All right, now I should also mention too that you can do programming on Magic-1 now, but the full-blown ANSI compiler, LCC, does not itself run on Magic-1. It's just way too big and probably always will be. But we do have a C subset compiler, the small C compiler, that works just fine on Magic-1. So let's go ahead and just look at, I've got a sample C program ready to go. So let's go cat hello world.c. And you can see the dialect is a little bit strange for small C compiler, but it's it should be recognizable to C programmers. It's just going to go through a loop and print hello world 10 times. And let's go ahead and kick that off. So we go cc minus O, hello world.c. And I've got it set up so it'll tell you what's going on, because it does take a while. I want to make sure it's still working. SCC is the small C compiler front end. And now it's converting that into an assembly file, hello world.s. Then the AS here, hello world.s, that's my assembler now running natively on Magic-1, and it's going to assemble hello world.s into a relocatable object file, hello world.o. And now we've got the linker running, and the linker is going to combine hello world.o with a bunch of other files and the C library to create a hello world executable. And it does take a moment here because the assembler and the linker are not especially speedy. I had to do some things to get it to work on Magic-1. Basically, I'm using the file system as extra storage to make up for the fact that I can't have more than 64 kbytes of active RAM for the linker process itself. And at some point, maybe I'll try to make the linker and the assembler a little bit more efficient, but it does work. Okay, so now it's completed, and let's go ahead and run that program, /hello world, and there we go, hello world times 10. Another language that's available on Magic-1, which probably very few people would know or care about, is Pascal. When I was first getting into computers in the early 80s, Pascal was the new hot thing, and that was actually the teaching language at my university. And back in 1984, I actually wrote a Pascal compiler targeting the Z80 processor, and I eventually got that bootstrapped onto my old TRS-80 Model 1 so I could have Pascal programs for my Model 1. And it was fairly simple to do. Early on, I changed that program so that instead of generating Z80 code, it generated Magic-1 code. So let's go ahead and do one here. PC for Pascal compile, minus O civ, oopsie. Well, am I calling it something else? pciv. Oh yeah, I'm calling it pciv, for Pascal civ, pciv.pass. So this is the old Byte magazine benchmark, the Civ of Eratosthenes, which I'm probably pronouncing wrong. And they're the Pascal compiler. My Pascal compiler from 1984 is reading the Pascal, converting it to an assembly file, and now the assembler AS is assembling pciv.s, and it will create pciv.o, the relocatable executable. And this one will take a minute or two, so I can kind of keep talking here. There's actually kind of some funny stories behind that Pascal compiler, but if you want to hear them, you'll have to buy me a beer and hear it in person. So keep that in mind if you ever cross paths with me. Okay, so now we're firing up the linker, and in a moment or two, we should have an executable benchmark of the Civ of Eratosthenes. Anytime now. If you could see the blinky lights so that I can see Magic-1, it is flashing away. It does have to do quite a lot of work, the linker. It's got to actually search the libraries, pull in the external routines that have been referenced, combine them all together, and fix up addresses. And there's quite a lot of file activity going on. So we'll get there eventually. Come on, you're not dead, are you? Of course, back then, this was probably the kind of speed you would expect to have doing compilers. I remember in my first job, it was kind of typical that building your program could take, a half an hour to an hour. And that actually did change the way you programmed. You thought much more carefully about trying to find errors by looking at the code. Okay, so now it's compiled, but what I should have done beforehand, let's go ahead and take a look at the program. Well, let's go cat pciv.pass. Let's just do a more on that, rather. More pciv.pass. And because I don't know, folks may not be familiar with what Pascal looks like. So this is a prime, it finds prime numbers. And there we go, that's a little Pascal. And then the output of the compiler, let's look at that. More pciv.s. This is what the front end generated. And it includes kind of the source code. Oops, let's go more. And then this is Magic-1's assembly language. And I had it arranged so that the source code would then be followed by the assembly language that was generated. And this was a very simple compiler. It used a recursive descent stack arithmetic. But anyway, enough of that. So let's go ahead and run it. .pciv. And it's going to run through 10 iterations of this benchmark and then tell us how long it took. And I have C versions of this that go much, much faster. I think the C version of this is like 3 seconds, maybe 2 or 3 seconds. Okay, so now you can actually do programming on Magic-1 itself with assembly, the C subset, or Pascal. And there's also a little basic interpreter on there. Now this, of course, the computer languages interest me because professionally that's what I did. I was a compiler person, specifically JIT compilers and dynamic translators and fast interpreters. So, you know, it probably tickles me to have this work more than other folks. What other folks may find more interesting is the other big thing I've gotten, a couple other big things I've gotten going on. I have a new game program that I haven't released publicly yet, but it means a lot to me. One of the games I played a lot in the 80s was a roguelike game called Larn. And I should turn off my little notifications there. A roguelike game called Larn. And so let's go ahead and run that because it takes a while to come up. .larn, and we'll go with the basics. And this one took me a long time to get running on the machine because it used so much memory. And so it actually, I had to put quite a lot of effort into this. I had to break the program down actually into multiple processes. So right now, preparing the dungeons is a separate program that's creating the dungeons we're going to crawl through and then writing them out to a disk file. And then the dungeon preparation program will exit and exec the game playing program, which will then use the saved dungeons that are out on disk and do the game playing. And then every time you kind of transition between levels, it actually, you know, flips back and forth between these programs. But I was just thrilled actually to get this working. I put quite a few hours into it. But it's a basic dungeon crawler type of game, probably not much different than Larn. In this case, you've got somebody has to go through the dungeons to find a antidote for his daughter, who needs it to live. And so now this is kicking off the game playing portion of it. And so here, because we're dealing with 1980s graphics, which is basically no graphics, I'm the cursor that I'm moving around. The E is the entrance to the dungeon. The $sign is the bank. H is the home, and various. Well, let's just go into the dungeon. We'll go inside. And now we can walk around. Let's see if we can find somebody to fight or some treasure to get. So there's a potion. Let's drink the potion. My vision has sharpened for some reason. Oh, there's a bat. And so I'm very low level, so it's hard for me to kill the bat, but it doesn't do any damage. So now I'm going through the dungeon. A magic scroll. Let's read the scroll. And it was oops, here's a kobold. Here's a critter that's going to come try to kill me. I'm running away, but let's go ahead and fight now. Whoops. And ignore that. Oh, let's ignore it. Sorry, I'm not used to typing in this position. Okay, now we're going to fight, and we killed it. Okay, anyway, we'll get out of that. But I will, fairly short order, I'll make that available to folks. Now, one last thing before I go here, that again, probably I think is more interesting than many folks would, is I actually now have a debugger that will run on Magic-1. And it's probably a topic that I could talk on for quite some time, but getting a debugger working is surprisingly easy. There's only one system called ptrace that you need to get working to have a basic debugger going, and this came up fairly quickly. So let's go ahead and debug something. So let's say the word count program. So let's go ADB for assembly debugging, user bin WC, and we'll just do the word count of, let's say, the psiv that we just looked at, psiv.pass. Okay, now it's firing up, and over here we see it's starting at 0, and that's the first instruction it's going to execute, and we can single step. So we'll go next. It's loading, copying, load effective address, add, and so on. And I can set breakpoints and do back traces. And another interesting thing it will do is I can do a system call trace, an strace. So let's turn that on. And this is going to tell me what system calls were called. And I'll just continue. And so it's going to go ahead and do the rest of the program. And you see that it's going to show all the system calls that happened. So break is dealing with malloc, and then read, that read, I'm sure, the 924 bytes of the file. That final read there was to say end of file. And then here we're printing out the ioctal is, actually, no, the write there comes back. That's what we wrote to the screen. And then lseek and close is sort of shutting down, and now it exited. And again, that's something that I'm happy about because it once more, it makes this feel like a real computer to me. I can now do software development on it, and I have an actual debugger, and that makes me happy. All right, well, this has probably gone on again way longer than I expected. If there's, again, more things about the software that you'd like me to talk about, be sure to leave a link. And once again, if you're anywhere near Seattle on March 21st and 22nd, 2020, come on down to the Vintage Computer Festival Pacific Northwest and see Magic-1 and me in person. All right, thanks much.